Let's talk about effect of temperature on solubility, where we'll simply discuss the solubility curves. Let us look at the effect of temperature on solubility of potassium chlorate. And we want to use a data of temperature and solubility. So that is mass of potassium chlorate in grams per 100 grams of water. Then we shall have temperature. A temperature of 88. The mass, or rather solubility, is 40. 52. Solubility of 20. 38. Solubility of 13.3. and 31. Solubility of 10. 25. Solubility of 8.0. Let us plot the graph of solubility against temperature. So we have the y-axis is solubility, then the x-axis we have temperature. So this is the y-axis. Then we have the x-axis. That is 0. Then 10, 20, 30, 40, 50. And this is our y-axis, and this is x-axis. In the x-axis we have this as 20, 40, 60, 80, and then 100. So the first plot is, remember, this is temperature. Then we have solubility, and that is in grams per 100 grams of water. The first plot is temperature of 88. This is 80. This is 90. So 88 is here. So 88 against 40. That is 88:40. Then we have 52:20. 50. Then 52 against 20. There is 38:13.3. This is 38 along the x. 15 is here. So 13.3. Then we also have 31:10. 30, then 31:10. Finally 25:8. The middle, then up to 8. So close to that. Then we want to join this to draw our graph on solubility. A smooth curve, and this is for potassium chlorate. Smooth curve of the solubility of potassium chlorate against a temperature. You can see from the graph that increase in temperature results into increase in solubility. Like when the temperature is 80, solubility is higher, and that solubility is 50 degrees Celsius. 50 grams, per 100 grams of water. When the temperature is 60, the solubility is now lower. So this is at 60, this is at 80. You can see from there that the solubility is simply directly proportional to temperature, where temperature increase results into corresponding increase in solubility. Meaning, as the temperature rises, the solubility of potassium chlorate increases, and for most salts, solubility increase with the same rise in temperature. However, the solubility of such salts, such as sodium chloride and calcium sulfate, remain almost constant with the temperature change, while the solubility of salts such as calcium ethanoate decreases with increase in temperature. And you can see that by simply looking at different solubility curves. Let us now have a series of solubility curves that we can use to simply analyze how different salts dissolve in water. So this is the grid we want to use to sketch solubility of different salts. And to sketch solubility of different salts. We have the x-axis as usual, temperature, y-axis is solubility in grams per 100 grams of water. So in the x-axis we can have 10, 20, 30, that as 40, 50, and then 60, and that is in degrees Celsius. In the y-axis we can have other units as well. Ten, 20, 30, 40. Now, for example, for potassium nitrate, the curve will take that shape. For sodium chloride, the curve takes that shape. Potassium chloride, that is potassium chloride. Potassium nitrate, we have seen an increase almost from 0, taking that shape. And calcium sulfate, almost a straight line. So that one is for calcium sulfate. So the first curve, this is for potassium nitrate. These are sketch for potassium chloride. Then this is potassium chlorate. And then we also have sodium chloride and calcium sulfate. So these are the sketch of simply for different solubility curves. Let us now look at the last part of these curves, where we want to use our curve to determine solubility at different temperatures. Use of curve to know the solubility at different temperatures. The question is as follows. Study the solubility of potassium chlorate below and use it to answer questions that follow. So we want to draw a curve of the solubility of potassium chlorate. So this is y-axis, then we have x-axis. So we'll have that as our x-axis. Then we have what we call y-axis. So this is 20, 40, 60, 80, 100 temperature in degrees Celsius. Then y-axis is solubility in grams per 100 grams of water, and that is 10, 20, 30, 40, 50, 60. So let's plot. We have 100, the first plot is 2510, then we have 60 to 30, Then we have 154. Then we also have 40. Seventeen. 40 with 17. Let's try to join these points to have our solubility, then use it to answer the questions that follow. Good. So that is the solubility curve of potassium chlorate. Question: find the solubility of potassium chlorate at 90 degrees Celsius. So to answer that question, we get to 90 degrees Celsius, then we draw a line. So this is 90 degrees Celsius, where we have that straight line, and then against this side, that is 90 degrees Celsius. That gives a solubility of around 48 degrees Celsius. That is solubility of 48 grams per 100 grams of water. Good. B, a solution containing 30 grams of potassium chlorate per 100 grams of water was cooled to 25 degrees Celsius. A, Roman 1 will be Roman 1, at what temperature did the crystals appear? Let's first answer that question. First of all, we'll look at the solubility at 30 degrees Celsius. So it is 80, not 30, but 80 and 25. At 80 degrees Celsius, cooled to 25, then what temperature did the crystals appear? So first of all, 30 degrees Celsius gives 64. So that is 30 degrees Celsius. If you narrow down that to the line, so the answer is exactly 64 degrees Celsius. That is Roman 1. That is 64 degrees Celsius. Then what was Roman 2? What was the mass of crystals obtained? So the mass of crystals obtained will work out some subtraction, which means we are going to read at 25 degrees Celsius and that 30 grams. So let us get the solubility at 25 degrees Celsius. The solubility at 25 degrees Celsius, exactly 10. So that is that 30 which was used minus 10. So that gives 30 grams minus the 10, giving 20 grams. Now, solubility at 25 is 10 grams. We are saying that the solution had 30 grams of the solute and therefore 20 grams of solute will crystallize. Solute crystallizes. So that is all about solubility curves. And remember, the first thing we just plotted the curve, then we generalized the way different salts have different curves, and finally we have used our curves to determine temperature and solubility.